Today we're going to be working on some more factoring of x squared plus bx plus c. And for all of those One Direction fans out there, this is a One Direction store in the Mall of America. I did not actually go inside, but I did take a picture of it because I knew some of you guys were a little on the obsessed side with them. First things first, zero product property. We've talked about this a little bit before, but just a refresher. If two things multiply to equal 0, one of the two things must be 0. So for example, if you have x times y equals 0, then either x equals 0 or y equals 0. We're going to be looking at solving these equations in the form of x squared plus bx plus c. Step number 1, you first need to set the equation equal to 0. Sometimes this will be done for you already. Second, factor using the x method. Third, set each parenthesis group equal to 0. And then because of our zero product property, we can solve for the variable. Example 1, we've got s squared minus 2s equals 24. So the first thing I'm going to do is to set that equal to 0. So I've got s squared minus 2s minus 24 equals 0. So I can do that because that 24 is on the right side, so subtract 24 from each side, I end up with this. Now, zero product property, I've got to get to a point where I can actually use that. So before I can do that, I have to set up my x method. So let's see, factors of negative 24 that add up to negative 2. So let's see, factors of negative 24 that add up to negative 2. So let's see, that would end up being negative 6 and positive 4. So what we can do for that, we can type that in as s minus 6 times s plus 4. And that's still going to equal 0. Now, zero product property says if you have two things multiplying to equal 0, one of those two things has to be 0. So either x minus 6 is 0 or s plus 4 equals 0. We're going to have to work through both cases. So if x minus 6 is 0, s minus 6 is 0, change that variable there. If s minus 6 is 0, we're going to have to add 6 to each side. And we end up with s equaling a positive 6. If s plus 4 equals 0, subtract 4 from each side, and s equals a negative 4. So we have two answers when we're dealing with problems with an exponent of 2. Sometimes they're the same answer, but right now most of them aren't going to be. So we've got s equals 6 and s equals negative 4, and we can write that as s equals negative 4 comma 6. Now be very careful not to put parentheses around that because this is not an ordered pair. It's just a solution. Try this one on your own. Be very careful. I did not give you just a number by itself on the right side. I gave you negative 23m. So be careful when you work through this that you actually make that the middle term. Pause your video at this time and try it out. Did you get the answer, negative 1 and negative 22? If you did, give yourself a check mark. If you didn't, go back, really make sure that this is the middle term, and try that problem again. Our last thing that we're looking at is finding the zeros of a polynomial function. With polynomial functions, we have that function notation back again, or f of x equals 0. So we've got f of x equals x squared minus 14x plus 45. Don't get freaked out. This f of x really just means the exact same thing as what we've been dealing with. We just have a different way of using our notation. So I'm going to start out by replacing that f of x with 0. Same type thing next. I'm going to go through and use my x method. So I want factors of 45 that add to a negative 14. Factors of 45. Well, 9 and 5 work, and if I make them both negative, that gives me the negative 14 when I add them. So that means I have x minus 9 and x minus 5. And I'm going to have that equals 0 portion on there too. Zero product property, one of the two things has to equal 0. So either x minus 9 equals 0 or x minus 5 equals 0. On the first one, I'm going to add 9 to each side, which leaves me with x equaling positive 9. On the second one, I'm going to add 5 to each side, which leaves me with x equaling a positive 5. So it's the exact same up until this point. Now what we want to say for the next part, using a little bit different notation, we want to bring back that function notation. Since x equals 9 and x equals 5, we're going to go ahead and put that back in for the x in our f of x notation. So we're going to say f of 5 equals 0, and f of 9 equals 0. And that's how we will denote those two things. And I've got them switched around compared to where I've got these, but it's still the same thing. Homework for tonight. Make sure you are completely solving these and getting the two answers. Have a great evening.